we discussed about the DDL, DML, and DCL, TCL related commands. So using DDL, we can define the table definition. We can create the table. DML, we can perform all the manipulation, data related manipulation, we can do it. And what I did yesterday's session, I just showed you how to create, in the last session, how to create the table, all the things. And finally, we wrapped up the last session with the joins, right? So joins we discussed. And as part of this create table, I just show you, right? So we have something called identity, using which you can generate the unique keys for a specific column, the primary key column especially. For example, I have something like create table, create table here, create table, something like not null identity, and here the primary key, and then SSI employee ID, SI ID will say, and here the e name is varchar of. This is just to help you to understand how it works, the identity. So this one generates the unique keys and it inserts the data automatically. Okay. Incorrect syntax. No employee ID int not null identity. Identity. Okay. If I insert that, insert into employee 2, and here if I say you need to use single quote in the SQL server. Yes. Look here, in this case, I just inserted only one value, the employee name here. I did not specify any value for employee ID. The identity is a keyword using which we can generate it. Basically, it increments the key values here. Okay, this identity is a keyword using which, if you specify as part of a table definition or column definition along with the primary key, this one will insert the values. It will auto increment the values starting from 1 for the primary key column. Okay, you can use it for primary key column, unique key column. But the idea of this one is it generates, you don't have to insert any value for the employee ID. Behind the scene, even if you insert only one value for this, behind the scene, it generates the key and then it, it's kind of a default value. Okay, so it generates, if I insert another record, it will get incremented automatically too. This is the one you should be aware of it, but in the real-time scenario, especially the larger projects, we don't use identity instead, right? With identity, I don't know if the options are available. Again, it is the DBS task. Okay, so they will generate the keys, everything, and then they will store it there. Okay, okay. So as of last weekend, we discussed the left outer join, right outer join, full outer join, everything. The union set operator also we discussed, intersect minus we discussed, and then the except also we discussed, because the minus operator was not available here. And today what we will do is we will continue with the I don't know if I have the data here. Yes, this is my self join also we discussed. Okay, so left join. Okay, in this case left join I used it. Yeah, self join I requested you to try with that. And the next one is all the date part, everything. Okay. Next one is the 1 second. Just give me a second. I'm getting a call. அப்புறம் call பண்றேன்ப்பா. I'll call you later. Who said that? I don't know. Okay, what we'll do is now we will continue with the correlated subquery and then the normal subquery. What is the difference between those two? So these are the assignments. You can write a query to display name and salary for employees whose salary is not in the range of this one. This kind of assignment, you can give it a try. And next one is the subquery or nested query. So what exactly the subquery is all about? So we are placing, your query is placed within another SQL query. So this is my SQL query, okay, and select job from M where 7369. We wanted to retrieve only this record, fine. But if you see here, select employee number, e-name, job, where job equal to clerk. Okay. So in this case, okay, for example, if somebody is asking you, find out the employees whose salary is, let's say, more than the average salary earned by all the employees. Find the employees whose salary is more than the average salary earned by all the employees. So how will you find out in this case? This is my data set. How will you find out? You will have to use the average. Since I said average, I just write it here. No, here it is. I was driving yesterday. Just 1 second with me. For example, if you want to find out, if I ask you to find out those employees' salary is more than the average salary earned by all the employees in your company. So in this case, all employees, how will you find out? How will you find out? First, there are two steps here. First, you need to find out the average salary and then filter the employees based on their above the calculated average. Okay. There are two steps. How will you find out? First, you need to find out the average. Find the average salary. And second step is filter the employees. Filter the employees based on the output of the step one, based on step one result. This is how we find out, right? So in this case, okay, we have already created the tables in the last session. What I will do is I'll just, yeah, this is the one, average salary from him. So here already I mentioned it here, steps. This is the average salary as per the data set, what I have it here in my data set, okay? If I find out, this is my average salary from employee where salary is greater than 1283. So this guy is getting more salary, right? More than the average salary drawn by the all the employees. Okay, here what I do is I will just write a SQL query where salary is greater than. I'm going to use this query here. In this case, this is called my subquery. It is also called as a inner query. So what I used here was a comment, right? Just before this, I put two lines here. It is a comment. Hence, this will not get executed. Instead, this query will. Look here, both of them, are these two produce the same output? Yes, both of them produce the same output. But what is the difference here? Here I'm using the, see in this case, what happened? I just computed the average salary of all the employees. And then I have, see here, I use two queries here, two different queries. Okay, and I computed the average. The average was 19283, and I substituted this average here manually, and then I just computed. But here you don't have to manually do anything. So this is hard coding. What if tomorrow some other employees are joining? Even their salary is more than when when you take into account of the new employees later point when they join your company, the average will not remain same. All the employees average will not be same. It may be different. In that case, again, you need to come here and then you type the values. This is a manual thing. You don't have to. Here, instead, what we are doing is we combine these two in a single query. So here, what we are seeing is the subquery or inner query, and this one is the outside one is called your outer query. This is what your outer query. So in this case, what has happened here, the whatever the value is produced by the outer query, right? Basically, the outer query, the output of the outer query, the output of this, the output of this inner query drives the outer query. So this one obviously will give me 19283, and based on the output produced by this one, the outer query will get, the outer query will get filtered. Okay. So the subquery returns a value here, right? So this subquery returns a value here. So this is, we can call this also as a scalar subquery because this one returns only one value here. Hence we call it as a scalar subquery. So the scalar subquery, it always returns one row and one column. Okay, one row and one column only, it will return it. Which one? So this one, look here, this one returns one row, one column only. This scalar subquery. One row, one column. That's all. The scalar subquery. So we also call this a scalar subquery because it returns only one value, only one column. And here scalar subquery. And then okay, and what are the other things are there? This is my scalar subquery. And what other things we can, so we have something called nested subquery. Okay, nested subquery is also, for supposing you want to find out the departments whose salary are better than the average salary across all the departments. So you have two tables, employee and the store, right? You can find out, you can use a nested query also. Nested query, we will discuss it later. Okay, what I will do is, see, what is a nested query? A query as written within another subquery is called your nested subquery. Okay, and for example, here I just show you with another example. Let me just see here the same thing here. For example, specific department number. I don't want to see entire, all the employees' salary, average salary of all the employees. I don't want to compute it. Instead, specific department. Okay, and depart number is equivalent to select depart number. I don't know if I have data in that depart, where depart now is equal to finance. I think finance, and I created. No, syntax error. Okay, here I started the open braces, but I did not close it here. Since I need to put one more parenthesis here, let me just see how it works. Yes, it returns a value, but unfortunately, we don't have the data here. What I will do is I will just select only this query up to this, and I'm going to click on execute. Depart number where D name. We want to see the D name also. Okay, well, let me do one thing. Select store from. And here I just execute this accounting. Yeah, we don't have any other department like finance, since it is not returning anything. Let me do one thing, sales. Let me do sales. 1 second, let me just execute this one. Yes. Look here, this is your nested subquery. So now we have we have written within another subquery, right? This is my subquery, another subquery. This is called your nested subquery. Likewise, we can write even the complex query. And we have next, we have something else called multiple row subquery. This is a scalar subquery. This is called a scalar subquery. And the next one is multiple row subqueries. 1 second, let me just close my neighbor. It's a lot of noise. Let me just... All right, so we'll continue. See, the next one is the multiple row subquery. This is my scalar subquery, and next one is we will see multiple row subquery. Sorry, this is multi-row. Supposing I want to find out the employees, those on a salary that is higher than the salary of all of the clerks. Okay, job was a clerk, right? We want to see that one. And let me see if the all function is supported in SQL Server. So I remember very well in Oracle job, sal. Hardly few records are there. Okay, anyhow, we will see. Where salary, not sales, where salary is greater than, select where job is equivalent to manager. I'm not sure if all is available in SQL Server. Yes, it is available. Without that itself, it is working fine. What I will do is I will just put some sample data. I'll update it here. And here, okay, if I say where salary is greater than, so we wanted to display the salary of all the employees whose salary is more than their manager's salary. Okay. So if I execute this one, what is happening? Here we have only one record is there. We have only one record is there. We'll try to put some other data here. We want to display those employees are drawing the salary more than the manager's salary. Okay, three guys are there, three managers are there. Okay, fine. Now what I will do is I will just okay, so these two guys are getting more salary than the manager's salary. Now I just select these two things together. So manager's salary was 2975. And if you see Chris and King, these two guys' salaries are obviously more than this guy's salary. So in this case, what is happening is why it is called a multi-row subquery. In this case, this subquery returns multiple records, more than one record. Hence, it is called multiple scalar query. So it can return more than one row of the results to the parent query. This can return. So in this case, it return more than one row of the results to this parent query. This is the parent query. Okay, this is what your parent query, the outside, the outer query, or the parent query. This is your inner query. Inner query or subquery. In this case, the subquery returns more than one value. Okay, the more than one value. So the output of more than one value, more than one row, will be passed as an input to this one, and this one will fetch the data based on the output generated by this query. Okay. And the next one is the correlated subquery. This is so far we discussed about the subquery. Okay. So what is a subquery? What is a subquery? We are using a query within another query, right? We are using a query within another query. That is what your, or query placed within another SQL query. Query in a query. That is what your subquery. And we have seen what is nested subquery, And also, what is the scalar subquery, multi-row subquery? We have seen it. Next one is the correlated subquery. The correlated subquery is a subquery. That one uses the value of your outer query. So in this case, what happened? This subquery, it was nowhere related to this outer query. This is independent of the outer query. Now I will show you the correlated subquery. The correlate, in this case, in the case of correlated subquery, the inner query will dependent on the outer query. So how is that? I will just show you now. Correlated subquery. Here what I do is I just write select star from employee as even also where salary is greater than select average. Average is a reserved word and it's capital letter. Average salary from emp, the same table, but I give another alias as E2. In this case, where the E2 dot depart number is equal to E1 dot depart number. First, let us see if this query is working fine. Yes, it is working fine, no issues. This is what we are querying. So here also, this is my outer query or parent query. This is my inner query or child query. In this case, what happened? If you see here, the outer query E1, right? So E1 dot depart number, you are using it here. So right. So in this case, what happened? In the subquery, it uses the values of your outer query. This subquery uses the values of your outer query. This E1 dot depart number comes from this table. Okay. You are joining both these tables depart number, subqueries depart number, and then the outer queries depart number here. So in this case, what happened? This correlated, this is called your correlated subquery because this query is depending on the outer query's value. So because of this dependency, this correlated subquery cannot be executed independently as a simple subquery. Look here, in this case, this subquery can be executed independently. Okay, it will get executed. Okay, it produces the output. Whereas here, you cannot execute it separately because this value, E1.depend, comes from the outer query, parent query. So, and also this correlated subquery will get executed repeatedly once for each row evaluated by your outer query. This one will get executed repeatedly once for each row evaluated by the outer query. So this is also called as repeating subquery. It is also called as it's a correlated subquery or repeating subquery. They call it a repeating subquery. So what is the difference between correlated subquery and the normal subquery? In the case of normal subquery, there are two types. One is scalar subquery, multi-row subquery. In the case of normal subquery, the inner query based on the output generated by the inner query will get executed first. The output of the inner query will be driving the outer query. The output of the your inner query will drive your outer query. Whereas in the case of correlated subquery, the subquery uses the values of the outer query, the inner query, right? The inner query uses the values of the outer query. Hence, there is a dependency here. The correlated subquery depends on the outer subquery. Because of this, we cannot execute this correlated subquery independently. And also this one will get executed repeatedly as long as all the rows are getting evaluated. Okay, so this is the difference between these two. In the interview they ask you this. In the case of correlated subquery, the subquery depends on the outer query's value, whereas in the case of the plain subquery, it does not depend on the outer query. That is the difference between these two. It's very simple one. So now it is in the case of correlated subquery, one liner. The correlated subquery, in this case, it is a subquery that uses values from the outer query. The subquery that uses the values from the outer query is called your correlated subquery. Whereas in the case of normal subquery, it gets executed independently. First, the subquery will get executed. Sorry, the inner query will get executed. But here, what happened for each and every row? This one will, for every row of this column, right, a row, it will get matched with this outer query's row. Okay. The subquery, it uses the values from the outer query, hence it is called as a correlated subquery. And say, for example, another example is I wanted to find out all the employees whose salary is higher than the average salaries of the employees in their department. For that also, you can use the same thing here. For example, here, yeah, that is what I did it here already. Here the salary is greater than, so this is right, this is the one. Now, what is the difference between these two? I will just put it here. I will put it together so that so which one can I use it? Can I use correlated subquery, or which one is faster? No, it is not same, right? So select star from M, where salary is greater than average salary from M. Yeah, this is different and that is different. Okay. Here we are using the department number. We are combining the department number from these two things. Okay, so that is the reason why it is varying it here. The correlated subquery, it consumes more resources than your normal subquery. Okay. Where did I put that? Yeah, this is the one, right? So yeah, the outer query, main query. 1 second. Yes. But here we are checking we are joining the department number also. Okay. Now what you do is give it a try. Okay. In this case, yeah, you cannot do anything, right? So you cannot use the department number here. Based on department number, if you want to combine this, so try achieving this output using the plain subquery. See, give it a try, how you can, achieve that one. Okay. Is it possible to achieve that one? Okay. And also we have something else called the tools here, tool menu. We have SQL Server Profiler. And if you open this, in the performance tuning session, I explained you as part of the dash query, right? So I just used only one or two examples. There I used it, this one. Look here, the trace got enabled. So once you start this one, and it will run. Okay, if you want to pause it, you can pause it and you can start the trace. What it does is, whatever the query that you executed here, it will keep a note here. Okay, so how much time that query got executed. Look here, correlated subquery, select star. Once you open this file, the trace file will get generated. And then you can check here. The first one was the correlated. So second one was this thing. And you can see that how many reads happen, how many writes happen. And you can execute it more than once. And then check it out here. Okay, so that it will not be biased. And you can see the start time, end time, everything here, end time, and then the how many reads happen, how many writes, what is the duration. Okay, but compared to this one, the second one was doing good. Sorry, the second one takes more time. This one was not taking much time. So I don't know how many of you are aware, when in the case of RDBMS, once you in a first time when you execute a query, what will happen is the data is not available in memory. It'll read the data and then cache it in the memory. Okay. Hence, when you execute the query in the second time or third time, what will happen is, only in the first run, it will take some time to read the data and then cache the memory, load the data. The output of this query will get loaded in memory. Second and third time when you do it, it will be get cached in memory. And then, similarly, you need to execute it more than one time, and then you can. But here we are doing average on the entire table. Hence, look here, when you execute it more than one time, what will happen is both the query output get cached in memory. Hence, we can see there is a drop in the, the elapsed time. But still, if you compare to this line, look here, if you select this one, and if you go down here, you can see the queries here. Okay, it shows both the query. Look here, select average salary, and this one takes reads and writes, and you can see it here. And you have something called the execution plan is also available here. Inside level, yeah, include actual execution plan. Where is it? Got disappeared. The execution plan. Let me do one thing. I'll just move this up. Statistics, okay, and include actual execution plan. So if I execute it here once again, waiting for query plan. Like I have shown the logical query plan and physical query plan as part of DAX Studio. Here also it shows, what is the execution plan it uses. Nested loops inner join, compute scalar. Simple way of doing is when you hover the cursor here, and if you see a lot of statistics are there here, actual number of rows of all executions file, IO cost, the cost should be less. Whichever query, let's say you have written a query and you want to rewrite the query to see are there any improvement in terms of the performance. Okay, what you are doing is you are executing the both query. Okay, and then for each query with this execution plan, and when you see this, the cost should be less. Whichever query cost is less. But let's say I have two queries. Both the queries produce the same output. But of the two queries, which query is pretty faster? How will you determine that? So, using this, you can find out. Okay, you just keep the cursor over here, and then you can see here nested loops, all the things, the clustered index. It uses some kind of index scan. And each and every stage, it is doing that. It performs the inner join, and then it computes the scalar value and aggregates this one because we are using the average function. And then cluster index scan, it is using some kind of index on the primary key employee table, primary key column of my employee, right? It is doing the index scan here, and then it is doing it. And total cost, if you see here, cluster index, all the things, it takes this much. Okay, these two things, and finally this one. If you see here, the cluster index scan, So actual number of rows for all executions 5, estimated IO cost. If you see randomly, you will get to know that, the higher the cost, if you find it for any one of them, look here, a lot of process are there here, right? So here, each and every row of the inner query uses the value from the outer query. For every row of your outer query, the inner query will get executed. That is what is happening here. By seeing this execution plan itself, we can make out, right? It requires a lot of processing behind it, sorting all the things. And then if you see the cost, somewhat close, estimated row size 49B. Okay, and CPU, estimated CPU cost. CPU cost is 0.00. CPU and IO cost, if you see here, you will get a fair amount of idea. Higher the CPU cost, IO cost, then something wrong here. But don't, draw any conclusion by executing your query only once. So in the interview, they'll ask you, how do you make sure that your query was performing well? Okay, what it is, when we have a bad query, then the query was taking longer time to execute. And what we did, we rewritten the same query with different logic. And then we enabled the live query statistics, include live query statistics. And also we have enabled the execution plan. To include actual execution plan. Okay, this is the one. Execution plan is very important. Okay, so with the execution plan, you can understand. So look here, estimated query progress 100%, query 1, and this is 100%. And if you see here, the query it shows here, right? So okay, let me just close this one. So we have you just tell them we have an execution plan. With the execution plan, we go and check the cost. Both the queries producing the same output, but with the execution plan, we could see that query 2 was consuming too much. Look here, the query cost related to the batch 100%. And here, let me just execute this one. In this case, 100% only it shows, and here it is not showing the complete thing here. With Oracle, it shows everything in the summary form. But I don't want to underestimate this one because I have not worked extensively on this SQL Server execution plan. But I have some idea here. Okay. The simple rule of thumb is whichever query has lesser cost, that means that query is better. Okay. So that is how we make sure that, for example, query 1 and query 2, both of them produce the same output, but query 2 consumes less resources, less IO, less memory, which means that query is much more effective, much faster compared to the other one. So it uses index scan, behind this in nested loops inner join. It uses the inner join and then compute scalar value of 1. Okay, this average. Okay, stream aggregate. This aggregate value you can stream it, and then it does the clustered index scan on the employee tables primary key value. And while doing the join also, based on the index values, it is doing the join, cluster index scan. Okay, it is doing the cluster index scan. Cluster index scan is the primary key values, right, and the depart number will be kept together. In this case, what are the tables that you use it, that one will be available in the same place. Hence, it will be faster. The performance will be faster. Here, yes, it is doing this, and then stream aggregate and cluster index scan. Again, it is doing that. It is giving the output here. Okay, fine. So each and every query you can execute like this, and you can check this. And when you see the output here itself, we can make out the execution plan itself, bigger one here, but the outputs are not same. Okay, only if the outputs are same, then we can compare it, that one with this. Look here, lazy spool, a lot of things are happening. Simple rule of thumb is, you just check the cost of this one. And other thing is, other way of doing is this one, the SQL profiler. The help of SQL profiler, we go and check. How do you first of all find out which query is taking longer time? We enable the trace in the SQL Server profiler. And then what we do is we execute the query at least 1 or 2 times. And then we'll go and check the statistics here. and whichever query duration is more here, you can see the duration here more, right? So more the duration, that means those queries takes more time. And if you see here, and this is the one, look here. But again, one more thing that what you need to remember here is, you cannot judge based on the literally based on the duration here, because when you use huge volume of the data, only you will draw a conclusion. Reasonably huge volume of data, let's say 10 million records, they are using it. In that case, when you compare both the queries, query 1 and query 2, against the 10 million records, and if you come and see it, then you can draw a conclusion. Look here, when I select this one, the correlated subquery, and when I use this one here, also the correlated subquery, where is the other one? The other one, okay, so here in this case, correlated subquery 157, but here in this case, if you see, nothing is showing here. Okay, client process ID, nothing. And then start time, end time, you can see it here. With the help of the SQL server, we go and check the start time, end time for both the queries. And whichever query, this is another way of concluding it. Okay, whichever query takes lesser time, then we go by that. And also we check the CPU. Whichever queries takes more, say, the CPU consumes too much of CPU, it involves a lot of reads, then we conclude that that query requires a lot of resources. Obviously, it will take longer time to process it. So what is the alternative? We have rewritten the query with different logic, but both the queries are running, producing the same output. Okay, hence we are able to make out with the help of the SQL server with the start and end time, and also the resources like CPU, IO, whichever query took lesser, based on which we decided, okay, those query took less, those queries duration was less, and the resource cost like CPU, IO cost was less, then we decided that one was good. Okay, and then we used to check the execution plan. Okay, in the execution plan, but execution plan is a little bit difficult to interpret, but still, whether it is using index or not, we will get to know that. In case we have an index but it is not using the index, in that case it will it will literally slow down. It will do the full table scan. For example, here if I do this one, department number not equal to 0, since we have an index, when you create a primary key on any specific column, it will create an index also. Look here, cluster index scan, so it is not equal to 30. Okay, and if I execute this one, so there is a the query here, it is using the index here. Okay, it is using the index because we are using the depart number column in the var class. Hence, you have an index on this one because we created the depart number column as a primary key column. But whereas this is not from the department table, it is from the employee table only. But still, it is using the employee tables, the primary key only. It is using employee table, not the department number. And stream. Okay, so is there any way I can create index? So what you do is create index. I don't remember the syntax. It's all DBS job. But let us see if this works. To create syntax in your AMP. Let me go and check it in Google. On create on table name. Okay, on I should use on create index name on employee table on emp depart number. Now the index got created, and we will do this thing again here. It is doing something like semi-join. Okay, and clustered index scan pkemp. And here I have created the index on the depart number. Ideally, it should have used the depart number index to retrieve this record. It is not using that index, depart number index. Okay, if it uses the depart number index, let me just check whether we have the depart number 30 is there here. I just go here. Okay, let me see, not equal to 30. Results, if you go here, 3 records are there. Good. We have something called hint, but I'm not sure if that one is available here. Let me use hint here. So these are the things you can see. We created the index. Initially it was not using an index. And in the where class, we use depart number or we use the region column. In that case, if you if you create an index on the column where you use it more frequently on where class, it will improve the performance. With the index product go adventure works. This is one of the important database. Okay, you can download and install it. With that, I will give you assignment. You start work on this adventure works data set, hence you will learn a lot. Start from with index. Look here, you can specify this way. Use index into force the SQL server optimize to use a specific index. So here you need to use with the space equal to index equal to IND department. What is the index name? This is what the one we created on this table for this column. So we will tell this query to use this index so that the performance will be faster. Where from, okay, here is using the from clause itself. The from clause using where clause, I think it will not work. If I use this one, look here, it is using the index here. Look here, we force this query to use the index which I created it. Okay, and once you create, you tell them, in the where class, we have some region key. The region key will be used most of the time to filter the data. We use it in the where class more frequently. What they did, they are using the queries by joining multiple tables, but unfortunately, there was no index was available for region, number, column, or something like that. We requested them create an index. After creating index, we have something called hint, right? This is called hint. So using this hint, index equal to this one, we enforce this query to use this index to retrieve the data. Hence, the performance got improved. Look here, you can see IND department, isn't it? So it is now using the IND department index, right? Index, department index, it is using to filter the data. Hence, it will be pretty faster. So what do you mean by index, first of all? What is index? For example, you have a dictionary, the manual dictionary. Supposing you wanted to see specific words meaning, okay, nomenclature. So you need to, so they will have some kind of bookmark kind of thing, right? So where the N starts in that book, you directly go there. And then in that page, you go and check where NO starts, next one. NO, you go to that page and you can search it. Instead of going through the dictionary from the first page to till the end page, that is your full table scan. What you are doing is, since you have the index, which is nothing but the bookmark or something, some leaf will be there, right? You directly jump there, A, B, C, D, N will be there, alphabet thing. That's kind of an index. You directly jump to the N page, and then there you go and search it. So the index is something like that. Okay. So it'll not do the full table scan. It is doing the index scan. Again, index, you need to use it on a case-to-case basis. If your query has to return only the 30% of your overall total tables data, then you can go for index. If the query output produces 25 to 30% of the data, then you can go for the index. But even after creating the index, my query is not using it. So how do I enforce my query to use the index? We have with index. If you talk all the things, guys, definitely they will think, you can definitely ask more salary. You can tell them your 5-year experience. Believe me or not, in the industry, many guys, they don't know. See, the lot of things like DAX function, all things, syntax is available in the internet. I made your job simple. What is initial filter context, all the things, I explained it to you. With that, you go and learn it, practice it. Certain things you can learn it by going through some examples. You can, but certain things, these are all experience, right? So this is what is important. Even many guys don't know. But guys, believe me or not, this kind of thing will drastically improve your query's performance like anything. Real time scenario, we break our head like hell because it runs for 2 days, 3 days, 5 days, some queries. Believe me or not. So after, because the volume of the data is very, very huge, after introducing some hints, like not only index, likewise different types of hints are there. If time permits, go and take a look at that. This is the validation by attending this training program. Okay. So, and you go and check it, and Adventure Works data, it's really helpful compared to other RDBMS. They have given this demo database. You can install it. I will probably show you later sometime, and then you can install it. And a lot of exercises are also available on the internet. You start practice it, play around with the hint, everything works fine. But if you do all the things, you cannot say you are the master. But nowadays, remember that Hadoop has gained already a lot of popularity. Okay, Hadoop, there is something called Hive data warehouse. There are some customers, they are using Hive data warehouse. Okay, a lot of many things are there. Fine. So this is the one thing. If you tell it to the interview, they'll be very happy. They think that you are an asset for the company. Okay. Even we interviewed many guys. They put their profile, all the things. But end of the day, performance tuning. That is where we spend a lot of time. They want to see the report, especially the CEO level, VP level. It'll run for 3 to 4 days time, and finally it breaks. Time out. It causes a lot of frustration. Okay. So now we understood how to diagnose the query performance. Go to the SQL profiler and check, which query, or you can check the duration along with the query, and whichever query's duration is it takes more time. If you see, right, then that query needs some kind of treatment. You take that specific query. They'll ask you, how do you find out the long running queries? SQL profiler. We have something called duration. It is available. Start time, end time is available. With that, we are able to find the specific query was running for a longer time, but end time we could see nothing. That means it started 2 days back, still it has been running, and it consumes a lot of CPU, a lot of writes. But still, we have no clue when it is going to end. So what we do, we took that query, we killed that query with the help of the DBA. We asked the DBA to kill that query, right? So hence the query will not run because it consumes too much of memory. It takes longer time. Other queries cannot run. We asked them to kill it, and then we took that query, and then we ran that query against a small set of the data. And with that also we found it took longer time, and then we have rewritten that logic and we introduced the index. Afterwards, the query performance got improved drastically, and then we ran that query against the huge volume of data. This time, we could see that the query was performing reasonably good. Okay, we are able to improve the query performance by at least 25%. Don't say 100%. No one will believe. 20 to 25%, or even 25% too much. You can tell them 10 to 15% we improved the performance. So see, I literally don't know the syntax in SQL Server about this. Syntax, you can learn it from the internet. Examples are also available. But these kind of things are very important. Okay, how to interpret them, how to create index, how to enforce the query to use the index. All the things are very important. All right, guys. Now you understood what is the scalar, what is the difference between subquery and scalar subquery, and and we have learned how to diagnose the problem queries by using the SQL server, SQL profiler, and then how to enable the execution plan. Execution plan will also show whether this query is using the index or not. With execution plan only, you can find out the newly created index has been used or not. Okay. Even after that, you need to execute the query and go and check in the SQL profiler what is the duration. After introducing the creating the index, and after we made that index, after we made that query, or after we enforce the query to use the index which I created it, what was the duration it took? That's all. The before and after, it's something like somebody is going for cosmetic treatment. Before, after, right? Same thing here. 1 second. Something is boiling. What? So the next one is, what is the next topic? Next one is we'll jump into the stored procedure, how to write a stored procedure. So now what I do is I'll just stop this one. Otherwise, even this one will consume too much of memory, all the things. Okay, next one is the stored procedure. We'll see how to create a stored procedure. We already discussed about the group by, right? Group by is pretty simple one. Anyhow, we will see the group by little later, because that I think all of you are familiar with that one, right? Group by, because in Power Query Editor itself, I have shown that. Now we will take a look at the stored procedure. So what is stored procedure? What is a stored procedure? The stored procedure will have a batch of SQL code stored on the SQL server. It is the most used programmatic structure in the database. So in the case of stored procedure, what happens is the TSQL code is passed once and runs many times for stored procedures. The same thing is applicable for the stored function also. Okay. So why do we need to write, first of all, the stored procedure? It's something like reusability. Reusability. Once I, like a stored function, if I write a stored procedure, once I write all the logic, the reusable logic, right, inside my stored procedure, I can write once, use it as many times as you want it. So what is the syntax for creating the stored procedure? So you have something like create or alter stored procedure. For example, here, this is the one example. So the syntax for this one is something like this: create or alter procedure, and then your procedure name. Okay, and then yeah, as begin, like you see the below as begin, and then here you need to specify procedure body. Okay, what you wanted to do it, and then end. And how do I execute this stored procedure? I have created the stored procedure. How do I execute this one? You have something called begin. Again, you can use begin, but it is not mandatory. Begin and in between. Inside this body, you need to use procedure body. Sorry, not this way. You can simply say execute. Okay, execute, exec, your procedure name. If you execute the procedure name, it will get it. Along with that, you can specify the parameter also. If you have used any parameter, you can specify that here. So here, yeah. So once you create the next one is alter procedure. Okay, supposing, okay, I created a stored procedure, but I forgot to include certain things. Like importantly, I forgot to specify the parameter name. So how do I, again, you don't have to drop and recreate. You can use alter procedure, you can use the alter procedure name. There you can specify the parameter name and then the data type. But here we use the execute. Once you write the stored procedure, how do I call that? You can use the execute command. Execute is the reserved word and then the procedure name. Followed by that, you can specify the values. Okay, values for your parameters. So how do I drop the stored procedure? You can drop the stored procedure also, but in the real-time scenario, you will not have drop privilege and all. You can create the stored procedure. That's all. You cannot drop and all. Okay. And look at this example. Create procedure name, and then this is the parameter. Inside the parenthesis, you need to specify the parameter. But when it comes to SQL Server, the parameter name should be prefixed with the @ symbol, and then the data type, and then the output. So here, the case of stored procedure, we can use input as well as the output. Okay, as begin and then select count or star, something like that. Let me do one thing. I have in the interest of time, I will just open it. This is a simple example. Look here, in the stored thing, right? In the sales database, first go to the select the database, okay, and then in that database, what you do is in this specific database, I want to create this stored procedure. If the stored procedure already is there, you drop it. Okay, it is not there. Okay, fine. Next one is I'm going to execute this one. Here, what is my syntax? Create procedure name. This is my parameter. Follow. You can specify it in a parenthesis also, or you can specify like this also. A date, comma, date. So what is the date? Date is my data type. What is this parameter data type? Date. And as is the reserved word. So create procedure name as begin and then inside of this you need to specify your logic here. Set no count on. This will not display certain unnecessary messages here. Hence we put set no count on. Select star from this one. For example, I wanted to pass whatever the data that I wanted. I want to pass whatever the date I needed, but the stored procedure should return based on the date that I specified. That it should return the output based on the date that I specify it. Okay. So in that case, I created it once, and now I can use it as many times as wanted. So how do I execute the stored procedure? Exec. This is my stored procedure. It got created, it got parsed in the sense any syntax error is there. Okay. And but semantics error, it will not do it. Syntax error, nothing, no syntax error, nothing. And then it generates the query plan, everything, and then it creates the stored procedure and store it in your SQL server. Okay, I'm done with creating my stored procedure. And here, how do I use this? You need to use exec and then the stored procedure name. And then followed by this, you need to pass some value to this so that this query will become dynamic. You remember we discussed about query parameter in Power Query Editor. So whatever the value that you inputted here along with this exec command, this one will get passed as an. So here, this value assigned to the date, and this value will get copied here. Okay, whatever the date that you see, you don't have to see the log. See, in this case, hardly we have one-liner code. In the real-time scenario, you will be having multi-lines of code. So what will happen is you don't have to understand the internal mechanism or the complete business logic. Okay, all you need to do is just make sure that what is the stored procedure name and what is the value that in which all parameters are there and what value that needs to be passed. That's all. Or what parameters that I should use it in the stored procedure. Right? This is the one. The classic example is like, for example, in the case of a real world scenario, what we do is we have the staging area. Sorry, you have the OLTP system. This is where all the orders that you raise it with my company. For example, I run an e-commerce business. All your orders get stored in this database, OLTP. And then what we do is we just simply extract these data and then extract. Simply read the data, use the select query, and then load it into your staging environment. This is also in a database, kind of a database. Okay. But it's a temporary area, temporary database. Okay, temporary database. You just think that way. And then finally, what we do is You extract, or let's say 10 tables from OLTP system: customer table, address table, order master table, order detail table, purchase table, purchase header table, and shipment table, vendor table, all the tables that are required for your analytics. Only those tables you extract it. Simply you read it and load the data here. Temporarily you park it here. Okay, and then next what you do is you, in this temporary area, you do all kind of data transformation. Okay, you can see it's something like in your apartment. You cannot, because your house is very small, you cannot do all kind of furniture job. What you do is you take it to the common area. In the common area, you do all kind of cleaning, cutting, everything. Similarly, we do all the data pre-processing, and here we do the data transfer everything. And finally, this is your data warehouse. In the data warehouse, we load the pre-processed data, pre-processed, if possible, aggregated data here. Okay, in this case, what happened? Okay, in Power Query Editor, though we can use direct query, everything, all the fancy time, everything is fine. Query folding is a fancy time, everything. But end of the day, you can't even merge the column. You can't even split the column values. You can do very moderate data transformation. So in that kind of situation, you can use your the stored procedure. You can create everything. And here, importantly, why I explained this one was, for example, in the OLTP, you have two tables. Customer table is there. It's a master table, and then address is another master. They call it as a master table. Okay, it's kind of a dimension table, but it is not exactly dimension table. These two tables will get, we extract the data from these two tables, and simply we take the copy of this one and store it here. The same table will get copied here. Simply, in simple language, we can say these two tables will get copied here from source system to here. We just take the Xerox copy of this one. We just take these two tables, simply copy here, that's all. But this table will not be up to date compared to this one. So what they do is every day they keep loading the data here, and then what simply you are loading the data, and then what you are doing is you are combining these two table data. You do cleaning, data cleaning, everything. For example, in the customer table or address column, you have some inconsistent values, or there's some blank values or duplicate values. You remove it, everything. You do cleaning, everything, and then you combine these two tables data, and then you load it. These two tables data you will be loading into data warehouse dimension table called customer dimension table. Dim customer is nothing but customer dimension table. But according to us in the star schema, I shown you only one customer dimension table. But for this, where the data comes from, OLTP system data comes, the customer at these two tables. But if you see the adventure works and all right, so many tables are there. Almost 10 tables are there. 10 tables, they combine it, they process, and finally they load it into dim customer table. Okay, so these two tables you join it, and so this is called, see, in the source system they normalize the tables, but in the data warehouse they denormalize the table. That means combine multiple table into single table. But that doesn't mean blindly combine all the tables, all the customer related tables, whatever you have it, you come, because in the source system they don't store the customer detail in a single table. They split it and store it in more than one. Customer ID, customer key, customer first name, last name, start date, and sorry, not the start date and the address they give a separate table. Here you will have address ID. So for this customer, if you give this address ID, and no, it's kind of one to many kind of thing. Okay, finally, what in two different tables to hold the single customer table data. Even for a single customer, their information will store in two different tables. But we don't want to have so many tables when it comes to data warehouse. The principle when it comes to data warehouse is reduce the number of tables. When you have more number of tables, and if you join is very expensive operation. More the table, if you join it, the performance will be slowed down. Hence, what you do is you try to combine the data, as much as possible, stored in a single table. This is called denormalization. Normalization, denormalization. Okay, these two table data should go here. Only when this table data get loaded successfully, next one is your fact table should load here. I call this here, this one is a predecessor table. predecessor job. This is called your successor job. Okay. For this, see, we need to every day extract the data from these two tables. If any new customer comes, then you need to insert it here. You need to do a lookup here. First, you join these two tables and then you load it here. Before any new, let's say today 100 new customers came and purchased. So go and check, do a lookup here. If the customer is not available, you need to insert this new customer here. And then what you do is you need to load the order table data. You need to load in your fact table. The fact table is your order fact table, something order fact table. Okay. Because in the order fact table, you are using the customer key column here. Not only the customer table, product dimension table, all the tables. Look here, dim product table, dim product is another dimension. And then what else? You have dim store, dim region. All these dimension tables should get loaded first, and then only your order table should get loaded. If any one of the job fails, for example, if this job fails, rest of the jobs will not run, it will get failed. They have written something like, if any one of the job fails, you stop it. Don't run other, because if it fails automatically, here also it will fail. See, the new customer came. For him, it generates a new key, customer key. It will get inserted, but that was not inserted. And forget about other dimension table. Now what you are doing is you are inserting the order related to this new customer. While inserting it, it requires customer key, isn't it? Because the fact table consists of the combination of the key column and then the facts, which is nothing but the numeric values. For the new customer, first of all, the new customer key was not generated here. On top, if you go and insert something, job will fail. It will get rejected. Okay. So for this, what we do is we will keep a lot of checks and balances. We keep something called control tables. Control or audit tables. If you tell them at the time of interview, they will think you really worked on the real time. Control tables or audit tables, we use it. First of all, what we do is, yes, the data, forget about the job failure. The customer and address table, new 100 customers came, the data got combined and then inserted here. What we know is this audit tables, what will happen is from OLTP to staging, whatever the job you created it. For example, you create a stored procedure, simply read the data and select star from customer, insert into this table. It's a simple query. Okay. In that case, what we one-to-one, you can use SSIS or you can use stored procedure, simple SQL thing, right? You can insert it. But whatever the number of new customers they came in, or all the customers got inserted successfully or correctly or not. Supposing in your table, you don't have sufficient storage, only partial, out of 100 customers, only 80 customers data will get loaded here. There could be chances. You have something called table space. The table space, if they don't allocate, the DBA don't allocate sufficient space, or due to phenomenal growth in the volume of the data, already it would have got exhausted with the storage space. Right? In that case, while loading today's 100 customer came here, only 80 customers got loaded, remaining 20 customers, it did not load because of space issue. Note down, in the interview, you tell them. Okay, those 20 customers related data key will not get generated in your customer dimension. What will happen is, for those 20 new customers alone, when you insert the data here, it will not get loaded, it will get rejected. So what you do is, here we have audit tables. The audit tables will capture, what time the job ran from OLTP to staging to pull this customer data and, insert the data here. What time the job started, what time the job got ended, and what is the status of the job, whether it succeeded or not. How many number of records were there in the source system? How many number of records got loaded here? Syntax, everything you can read it in the net, but this you cannot, read it, right? So that is what I'm saying. 100 records, 100 records. Okay, then you can make sure this is called reconciliation, technical reconciliation. Technical reconciliation. Okay, technical reconciliation. And what we do is here, see this one, what will happen is once you read the data and load it here, and then from here to if you load it, there are some cases they use triggers. This is where the triggers will come. So as soon as the data get inserted here, this table will create the, the trigger. The trigger, what it does is goes and insert one record in your audit table. Hey, today by 8 a.m., the data got inserted into customer table. And how many number of records? It will give you the count. We store the count. We use the logic, select count and all. So right, and then the according to us, take the customer data from here, select star from customer, insert into this table. Since you have created the trigger on this table, the trigger, whatever, once the data gets loaded here, it will write one record in the audit table. In the audit table, we have something like job ID, job name, start time, end time, elapsed time, and then job status successfully installed. And in addition to that, it does the count also. So source system customer, we have 100 records. The staging also 100 records got loaded. With that, we are able to understand both the values are this is also called data reconciliation, technical reconciliation or data reconciliation. When I worked Wipro in the past, we use different terms. Okay, data reconciliation, technical reconciliation, business reconciliation. Okay, data got loaded, whether the data got loaded correctly or not. Okay, for example, in the staging table, we have something called order detail table is there. Okay, and then order header is there. Here, what will happen is in the order detail, we have something called sales amount column is there. The sales amount column, we have mentioned the width as this, 8, 6. 8, 2, sorry. Okay. So the total width is 10, out of which 8 integer and 2 decimal values. But the same order detail table here is available. I just copy paste it here. So this one, we just copied from here, right? We just copied from here, staging area. From the source system, we copied here. But in the source system, it was 10, 2, but here 8, 2. Value 100 records, listen, order detail also, you have 1000 records, 1000 records got loaded, correct. So when it comes to reconciliation, done. Data reconciliation, all the records from source system correctly loaded here. With that itself, we cannot conclude it. The data got loaded, how complete the data? Here, for a specific transaction, the sale amount was 100,000, let us say 100,000. Since you don't have sufficient space, still the data will get loaded. It will truncate the value. Instead of 100K, it's say 100,000. It will show, just 10,000. For that, what we do is, these kind of columns, numeric column, we do the source sum of sales and then target sum of sales. We do that. All this logic, we implement it as per the trigger. Got it? Fine. So the trigger will load the data in this reconciliation, but these tables are much, much smaller compared to your actual business tables. Okay, these were technical tables. These were here we are just auditing it. Okay, which all tables. So look here, I just show you since it is more related. I'll just show you with this example here. Look here. So again, there are cases they want to know what time the data got inserted, what time the data got deleted, updated. This is a classic example. Look here, you know what? This is what my employee table, you know very well. This is my employee table. Okay, what we need is we wanted to create a log table. This is what audit table, okay. What I'll execute this one. This already executed. This table got created. Cool. And once again, I'll check. We have this many. What I do is I create a trigger on the employee table. Which one? The original table. This table I'm creating index. Okay. Look, trigger. So this is a syntax. Create trigger name on which table? Employee table. For insert. Whenever any new record get inserted in this table, you just store it in employee log table. So that later point in time, which date, what time, which customer record or employee record got inserted into this table, that we can capture it like CCTV. Look here, this is my trigger syntax. Okay, already it got created. Now what I do is I'll just query it one more time. Look here, how many records are there? 6 records there. And I'm going to select this table, log table, 3 records are there. So what I will do is I'm going to say another number, 47. And then instead of Chris, I say, Krish. I'm going to insert new guy. Fine. So what is the big deal? Employee table new, whenever new employee comes, we are going to insert their data. Likewise, I insert the data here. So note down the employee is, now it is different. I just check whether this new record got inserted simply. Yes, this got inserted. Fine. But the employee, but here, later point, if they ask, hey, there is something wrong here, man. What time this record got inserted? We want to see that. Can you give any answer to this? Right? So can we use this one? Right? So now Priyanka, I'll come back to this, very important. Okay. So let me finish. Okay. Select her question is, can I use direct query or import in this one? Right. So look here, this is very important. Look here. Did I insert anything in the employee log? Nothing, right? I inserted only in the employee table, this new record, new employee number. Automatically, so since I created a trigger on the employee table, as soon as you insert any record in this table, you insert a record in the employee log table. After insertion, after completion of the insertion, you can also put one entry in this table. So that later point in time, we can check what time this employee ID got inserted into my table. For this purpose, we use trigger. Trigger, everything is there in the internet. Okay. If I don't know the syntax, that doesn't not, I don't know anything, right? So, but end of the day, when to use what, that is very important. That is what we are expecting at the time of interview. Okay. A stored procedure, yes. Our question is stored procedure, can I use in direct query or import? I think you can use it in import. Okay. You can use it import. Fine, now you understood what scenario, that is very important. You create the trigger. They'll ask you what is a trigger. Okay, fine. Trigger is, if any specific event, if you want to capture it, if you want to trigger a specific event, for example, insert, update, delete, what time a record got deleted, what time a data got updated. In that kind of situation, it's very, very helpful. For example, in the case of bank, so what time your transaction got updated, right? If somebody is deduct some money, what will happen? What time it got deducted? He wants to know. With the help of the trigger, it automatically triggers if anybody deduct anything from your account. Now you understood, right? This is the scenario we use. You tell them, so we need to. That is the reason why I'm spending all the time explaining all the things. Okay. Next one is the stored procedure. I have shown you. It's a very simple example. How to create. Let us go here and see one example. Look here. I have opened the. Already I've opened it here. And where is that? SQL tutorial. Yeah, this is where I explained everything, right? So the staging, here we do the data reconciliation. Once you combine all the again, after you load the data, here also you do the data reconciliation. And then, right, so that's all. And the fact table also same thing. Once you load the fact table, you do the consolidation, okay, the reconciliation, how many number record. So that end to end, this is called data lineage. For this table, what is the source? For this, the source is order header. And for this, the order source is, so for customer is the customer table and address table. These two tables are the source for this one. This is called data lineage. Data lineage. That is what the term you can find in the Power BI Cloud Service also. Okay, now you understood how to create a stored procedure. Look at this simple example. You can use whatever the parameter that you need, followed when you specify the data type, and then ask this So the interview, they will not ask bookish kind of question. Okay, if they ask and if you are not able to answer, that doesn't mean you are you are not bad. So the end of this scenarios matters. Okay. If you tell the scenarios, obviously, the managers are, the real managers are result oriented, output oriented. Look here, executive, look here. So if you specify any other date, so automatically it goes and filters it. So why I am saying here is, you can use the same thing for your source to staging. Insert, you can use it here. Okay, source staging, you can insert, you can use the insert here and select star from your source system and insert it in your this thing. So simple thing is like how will you use that? Insert into emp1. How do you create the clone of a table? Can someone tell me? How do you create the clone of the table? I want to create an employee, duplicate of an employee. How can you do that? Pravert, what happened? Invalid object name emp. Yeah, so now I think I was in the wrong database. And select star 2 into EMP. Okay, fine. Now what I do is I just truncate the data, select star from EMP to. Now we took the clone. I just put it here so that everything will be in a proper order. Clone. I took the clone and now what I do is I want to have the same structure of that one, truncate table EMP2. Okay, this if you select the employee table, nothing will be there, blank records. Now what we will do is select star from EMP, sorry, insert into EMP to select star from EMP, right? I think so. This is the one, yeah, correct. This is the statement. We use it from OLTP to staging. Very simple one, right? Most of the time. Simply copy paste the table from your, for example, in the OLTP, I have something called EMP table. And here I want to use EMP2. This is my temporary table. So for this, you can create a stored procedure. Okay, how do you create a stored procedure? Insert into EMP2, select star from, something like this. Sorry, this is the one like F5, yes, stored procedure got executed. Now what you do is simply execute populate staging. That's all. In this case, we don't have any argument. If you want, you can use any argument. And then now if you see here, if you execute it, yeah, 9 rows got affected. And if you go and check it in the M2 table, here here you just think there's no primary key, nothing. So hence it got inserted. So it got inserted. So this is the kind of stored procedure we'll be using it. Now you see, is there any way you can parameterize the table name itself? See if you can do that. Okay. So here parameter one, look here, in this case I use the parameter like this one, right? Is there any way you can parameterize the table name? Okay, think about that one. Okay, see if you can do it so that any table. So what they do end of the day, populate staging, right? So likewise, multiple tables will be there. So what we will do is we will, for example, the customer and address table, take that example. That is for your staging, transformation, right? Transform, another stored procedure. Now you moved from the source to, this is a source table to the staging table. From the staging table, what it is, let's say this is your customer table, address table. You join those two tables, remove all the duplicates, everything, and this customer name is available in a single column. Split the customer name as first name and last name you separate it. In the US, first name, last name, middle name, you need to separate it, and then you put the date of birth in some other thing. And then what you do is customer address, everything you can combine it, and then what you do is load it into another table, dimension table. This is what, but in the case of dimension table also, we have type 1, type 2. Instead of asking the basic questions, SCD type 1, you just go and explore it. The interview, they will ask you what is ETL and what is the SCD type 1 and type 2. This is where you can leverage me, okay? Type 3, type 4 is, how many SCD type 4 is there, okay? Slowly changing dimension. Type 1, type 2, type 3, type 4. So I'll just explain one example. For example, in this case, the product table, what we are doing is we insert a new product. Let's say you have something called hair heater or hair dryer. Hair dryer product is the Philips hair dryer. You inserted that record. Okay. And then product key, product alternate number, and then you have something product name, and then this one, the stock on hand, and the unit price, actually the cost price, okay, cost price, start date, end date will be there. Because the same product price will change later point in time. That is the reason why they store the history also. When it comes to type 1, what will happen is in your product dimension, you have the hair dryer Philips product is there already. Before you insert the data, see in the case of type 1, what will happen? Okay, today we change the price. But still what we do is we don't care about the previous price, simply go and override the previously existing record. What we do is, okay, from the source system, new product inserted, it will go and check the product is inserted. If the product is already there, but the price is not same, it will override the previous. But in the case of type 2, it maintains the history. Okay, what is the current price, previous price? As the name suggests, 2, it maintains only 2 versions, current version, the previous version. What is this quarter price for the hair dryer? Previous quarter, what is the price? Start date, end date, that's why they maintain it. And then, so, in some cases, what is, no, we need multiple versions because you want to do later point. So with this price, in this duration, each duration, how much price we quoted. And for those prices, how much profit we made. What was the impact? For that, they need multiple versions, SCD type 3 and type 4. Here, they mention the current record, current and previous record only. Current record, the current record along with the product name, all the things. So finally, they have something called the active status. It's a flag. So they put current record, they put Y here. You do Googling and see, if you are able to understand the concept, implement them in your stored procedure. That is an assignment for you. Take only one dimension table, and then for that dimension table, what you do is, if any new profile, I'll repeat here. Product dimension table comes here. Product ID is 100. It is already there. You do a lookup in your dimension table. Dim product. Okay. You do a lookup of the product. If the product is new product, what we'll do is, here we have the product number is there. Product number is there. And go and check whether this product number is already there. If it is there, in this case, what you do is insert the new, you do a lookup on this table. If this product number is already there, check the unit price and other key columns. Okay. The unit price of the previously existing, the same product price and current price is same, then you don't insert it. Okay. The hair dryer, already it is there in the product dimension table, but the unit price previously it was let's 2,500. But today the same product came here, but we are doing the lookup. Okay, in the product dimension, the same product number is available, which is nothing the hair dryer, but the unit price is different now. It will compare both. You implement the logic that way. Compare the price. If the price is different, okay, then you insert this record. Even though there is a duplicate, you insert. That is the reason why there is something called surrogate key came into picture. So you have something called product key and product number, and then you have the unit price, stock on hand, and active start date and active end date, and here's something called active, whether this product is good. So the product is already there. How do you check that? You do a lookup here. If the record is already there, what you do is you go and check whether the unit price of the previously existing hard drive and then the new record which came in for the same product or same. If it is not same, insert it one more time. So in that case, what we do is the product key is nothing but surrogate key. You might be asking, is the product number same, right? If you insert it, it will throw an error. In the dimension table, this is the primary key. This is not the primary key. It is called, that's why it's called the alternate key. This is your primary key, surrogate key. It is an artificial number, 1, 2, 3. Since the product number is already there, when you try to insert the same product number, it will cause duplicate issues. Overcome that, they introduce something called surrogate key. So 1, 2, it will generate automatically. Okay, and then with the combination of these two only, you can find out the product number uniquely. Okay, and then the active status. The product key is 100 is already there. I just type it here. The product key 100 is already there. Guys, this is very important, rather than completing the chapter and sending you, hey, we finished everything, right? This guy delayed, but take away how much? The active is your, initially why that one, but the same product came in here, again here. The 100 I put, same product comes here, you do a lookup, hey, it is already there. So in this case, what you do is, this is your product number. Here, let's say you have something called 101. What it does is, it is already there, and it will check the unit price for the same product, which came in my today's transaction. The unit price was, earlier it was 2,250. Now it is different, 2,150. There is some offer. Since these two are not same, you insert this product number again. But here the product key will change. This is surrogate key. Product is surrogate key. Product key is different. Product number is different. Stock on extra of them. Okay. And finally, what will happen is, in this case, hey, you consider this a current record. Why? And then previous one, you put no. This is what the logic I want you all to try it out. Let me see. Okay. Rather than going by the syntax, everything, better you go. Obviously, the syntax they will ask you some extent. But if you know this one, you can survive even after clearing the interview. When they give you the requirement, you will not struggle too much. Okay, because this price got changed for the same product. We inserted it. Importantly, here we put y here. This is the logic you need to implement. And then the previous record, you need to put it 1, n, because this became inactive, because currently this is the active one. Okay, and then start date, end date, you need to put it, so that later point of what duration we sold the product with this price, we'll get to know. So likewise, type 1, type 2, type 3, 4, everything, you go and do a lookup. Sorry, you you do browse it, and then you try. At this one, 1, 2 alone, and 3 also, understand the logic, but implement this in your Power Query editor. So do some Googling. Okay, SCD type 2 in Power Query editor, SCD type 2 in SQL Server Stored Procedure. So go and give it a try, practice it, and then come back with, hey, this is what my solution. You should be a go-getter. You just think that I am your American customer at this moment. Don't think I'm your trainer. Okay, if you do it, if you practice it now, so in the real times, you will not struggle. This is the question they can expect, ETL, all the things. There are guys, they said, sir, I cleared the interview, everything. But when I ask them, tell me what answer you give, with that itself, I can understand you will not get positive feedback. That's why go through on this and you clear. So, okay, stored procedure. Next one is the stored function. The stored function also the same thing. Okay, stored function. In the case of, what is the difference between stored procedure and stored function? This is specific to the the SQL server. You take any RDBMS, you can create stored procedure and then the stored function also. But stored procedure need not to return any value, whereas the function has to return the value. But otherwise, more or less same thing. But in the case of stored procedure, you can pass an input parameter and you can, pass the out. You can get the output also. You can assign it output also. Whereas in the case of stored function, you can pass the value and then you can return a value. The function has to return a value. Okay. That is what your stored function is all about. And the next one is, okay, before we jump in there, first we will, with this, I'm going to, it's already, 11 o'clock, we are close to, but good that, I covered important topics, which will help you to, give more confidence to the interviewer. So they will ask this question frequently. So how do you find out the top 5 salary, top 4 salary? Okay, you can simply say select distinct top function. See, simply you can see top to cell and descending. For example, here e-name, comma, salary. Will this work? Chris, and okay. So these top to salary descending order. Since it is doing it is sorting this salary column descending order. And then you have mentioned top 2, it gives you. Now the question is, I just wanted to see the nth maximum salary drawn by the employee, 5th highest salary, 10th highest salary drawn by the, how can I see that? Right. So in that kind of situation, what we will do is we can use the simple logic here. This is the third maximum salary drawn by the employee. Look here, I want to see only the employee who got third maximum salary. So now what I do is, for your verification, I'll just keep this one also here. This is a manual way of doing it. But in this case, if I wanted to see 25th maximum salary drawn by the employee, so in the first query, what will happen? 25 employees it will show, right? I need to see the 25th employee only. Look at 3 records. But if you see here, the 3 minus 1 is 2, right? Let me do one thing. Select star from. What is the third highest salary here? So these two are same, and this one is second highest. And what is this third highest? 2975. Look here. With this simple query, see, recently, another guy attended an interview and they asked him, how will you find out the nth maximum salary? He said, sir, I'll use dense rank. Dense rank gives me. No, you're not supposed to use analytic function like dense rank. Dense rank is an analytic function, and partition function, row number, these are analytic functions. It is also called a window function. Don't use window functions. Without using analytic function, how will you do that? So this is the logic, simple logic. Okay, select all the things, your select list, where 3 minus 1 equal to, or you can say simply 2, okay, where 2 is equal to select count of distinct of sal. This is what matters a lot. And again, here we have used the correlated subquery. Right, it takes the entire table data here, but where 3 minus 1, it takes the first 3 records, and then here what it does is select count of distinct cell. We are finding out the distinct unique values of the cell and how many number of time each and everything appears, and you are comparing this tables aliases the unique value with this value. Whichever values are greater than this one, it will be. But here I mentioned about 3 minus 1. So if you want to see the 4 minus 1, you can test it out. 2850. That is what we have seen it. The fourth largest salary is 2850. So look here, it ignores the duplicates also, right? So this is a very efficient query. And otherwise, if they ask, hey, is there any way you can use the rank function? We have something dense rank function. This is your what is that, CTE, right? There is something else called CTE, but here what we did inside this one, we specified the logic here. Dense rank is the analytical function over order by sales descending order. So you do the first, you sort the data in descending order, and then you give the ranking. Okay, and what you do is you display the distinct salary from employee table. Next, what I do is in the next select top one cell from result with where dense rank equal to NIST. Okay, there is something wrong here. Even this one also giving the correct answer here. But here, okay. Look here, with is a reserved word, but result is the name which we need to use. This is the CT name. What is that CT stands for? What is CT stands for? What is CT stands for? How many of you have this is very important thing? Okay, CT stand common table expression. The CT stands for common table expression. I just put it here. This is a very powerful construct. Okay, it helps us to simplify the query. So kind of modularity. Okay, here what I did first, I find out all the things here with the result. I'll store the output here. Next one is top one cell from the result where the dense rank is equal to nth highest. Here you just specify whatever the value. So how do you declare a variable? You need to define, supposing you want to define a variable, you need to use the reserved keyword declare. Followed by that, you need to specify the parameter, and then following you need to specify the data type. Okay. Set, this is another command set. You can assign a value to a variable like this. Here I assign 3. I wanted to see the top 3. So next, what I did, I just return this window function, or the rank function. It's an analytical function. Unique salary, you take it. In that, for each and every unique salary, you assign the rank in the descending order. Okay, sort the data in ascending order by salary. For the unique salary, put 1, 2, 3. Okay, you just query this one also here. Look here, it gives us the rank here, right? So here it gives me over order by salary, descending order. And then here it gives us the 1, 2, 3. See, highest value, it gives 1, 2, 3. So this is my unique salary, okay? And then, okay, don't ask me why it gives in the ascending order. Okay, what we will do is here, they have made, because I executed this one, I think because of this, it's happening. Okay, what I will do is, because I've used the this one here, right? I did not execute it correctly. That's the problem here and there. Common table expression here, the dense rank function, it assigns the rank. How did I check that one? This is the, sorry, not this one. And sorry, the object name result. You need to jointly select it and then you need to do it. Okay. Separately, you cannot see it. Okay, simply we can select this one, 5, 4, 3, 2, 1, right? Here it gives me everything. And the output of this one, see here it assigned the rank to each and every unique salary. Here 50,000 more than one time it is appearing in our data. You remember, but still, since we have used the distinct here, only the unique values are coming. It removed the duplicate. It gives 1, 2, 3, 4, 5 rank. And then, and then this output gets stored in a result. Now, simply you need to query this data, but top one cell from result. And here where dense rank, this is the one less than or equal to 3. So in this case, what happens? It gives me the, if you individually do it, it will not be available. So you need to 2975. See, since I mentioned 3, if you want to see the fourth, again, this is how you can use the dense rank. So in this case, you need to select the distinct salary, and then you assign the rank using the dense rank function in the the descending order way. Okay. But here I'm not sure. I forgot this. Why it it is showing in the ascending order. It's supposed to be in the descending order, but probably you can check it out. Okay. So this one approach. The other simple and plain approach is this one. The simple normal query, you can use it. So where I have used the count of distinct of salary. Count distinct of salary. So the same thing, distinct salary it will pick up so that it will eliminate the duplicates, and then it finds out the count from M to where E2 dot sal is greater. So in this view, whatever the salary is there, but here we have where 4 minus 1, which is nothing but 3, right? So where 3 is equal to, so this one. So this is the logic you need to use it. Or the other best thing, you can tell them dense rank. You can easily explain this one. Okay. And I've used the dense rank, CT expression. With that, you can do it. The other option is the row number. You can use the row number also. Look here, it assigns the, this is a very simple one. E name sal row number function. It's a window for, this is an analytical function over order by sale. Here we are, sorting the data in descending order. Look here, it works perfectly here. As nth highest salary from M. That's all, row number. But it gives us all the things, but we don't need all the things. We need to see with this, we can say, right, we can see fifth the top, all the things. Okay. And the next approach is this one. This one was not working. I need to check it. Invalid column sal. I'm getting something like invalid column as sal. Top 5, it will get passed here, and then you can try this one. Best thing, you can use row number. It's pretty simple, and then you can use the limit also, or you can assign create some parameter or variable, pass that parameter as a dynamic one, and then you can get it here. CT, you can use it, or you can use the plain SQL. That is also fine. The nth maximum salary they will be asking, you can tell them there are more than one approaches, or one is the dense rank function, we can use it, or other option is like count out distinct of sal. We can create the same table. We can use the same table. The subquery of the same table, what you will do is, will take the unique value of the salary, and then we compare it against the parent query's salary. Whichever is greater, that one it will return. So what we do is, we have where clause, we use 4 minus 1 or 3 minus 1, you can use it. So that here the first two record related to wherever the values are, the whatever the value that you specified, right? Second maximum, third maximum. For that, record, it will go and filter it, and it will give you that. More than almost 3 to 4 to 5 approaches are in the net. Probably you can, check it out. Next one is the stored function. This is the syntax for this. With this, please bear with me. Okay, this is the syntax for the create or alter function. And you can create a function like this. It's already late. What we will do is trigger also I covered today. What the stored function, we will continue. Tomorrow we'll leave it. A lot of headaches, or there some death happened, some procedure is there. Day after tomorrow, I will walk you through the project, and whatever the leftover will see it, including the dashboard creation, all the things. And first I will explain you the project, everything, don't miss out. And that is how you need to articulate with the prospective employer. If they ask you, they'll ask you as part of the screening, tell me something about the current project, what challenge that you post, how many tables that you use it, can you tell me the column names, and what kind of relationship that you use, Snowflake or star schema, which one is better. Okay, all the things they'll ask you. And project point of view, I'll explain what is the requirements definition, and what is the source to talk the target document, and all the things. Even today itself, the ETL pipeline I explained to some extent. We will see it in day after tomorrow night, say, the same time. Meeting invite remain the same. Okay. This queries, I will share it to you in GitHub. Okay. And I'll send you the link so that you can go and download it one shot. Otherwise, or else I will put it in my website. You can go and click on it, download it, and practice it. Some common table expression. Okay. Oh, okay. Priyanka, you answered that one, right? Common table expression is very popular nowadays because it's a very powerful. You can temporarily store the result. You can break down your query. If your query logic is very complex, you can break down your query into multiple chunks. It's kind of a step by step. You can perform the logic, and then you can temporarily store it into one variable, and that one you can use in a subsequent query, and then you can do it. So that later point in time, if you wanted to check in which part of your SQL query any issue came up, right? You can see it. See, no syntax issue, nothing. You join with multiple tabs, but the output is not producing the expected one. That is where you break your head like anything. So in that kind of situation, the common table expressions are very much handy. So in which point we are getting this issue, we can find out where the query logic was wrong. Fine, we are done with the SQL topic also. I covered all the important things, but in the interview, what they'll ask, how will you find out the duplicate records from a table? Okay, they will ask you that way. How will you find out duplicate records in Power Query Editor? How will you find out? You have duplicate records values there, right? Duplicate values are there. With that, you can find out. But in the case of SQL query, how can you find out the duplicate values? You can simply use the group by. Okay, you can use group by with having count of star. Okay, so with that you can find out how many number of in each group, how many number of records are there. Okay, count of star greater than 1, right? Select column name from table, group by the columns, whichever columns. For example, you have order ID and product ID having count of star greater than 1. So in that case, more than one record is there. That means you have a duplicate. So how do you remove the duplicate record? Group by, right? So how do you select star from, select all the columns, select, for example, select country, comma, sum of sales from the table name, group by country, having count of star greater than 1. But country will be there multiple time, but order ID and product ID. Order for each order, for example, your order number is 100, product, 1, your product ID is 1, that is hair dryer. But same hair dryer, same order number, it should not repeat. If it repeats, then you have duplicate is there. Okay. So how do I find out? Group by. Simple logic is select order ID. This is the composite key, right? So with that, you can find a count of star. You use count of star from order details or something like that. Group by. Here where is not required. Group by the order ID and the product ID. With the combination of these two things, you need to do it. Product ID and having count of star. So this count of star is very beautiful one. So how many of you are aware of this one? Count of star is greater than 1. So here we use where class, right? So we use where class to filter the data from our table. But here having count of star, we use it to filter the data on the grouped data. That is what having class is all about. In this case, for this combination of values, can you see anything more than one occurrence? Count is nothing but occurrences. How many number of occurrences? The value. Count of star tells us if you have more than one occurrence, then you have a duplicate. Next step is how will you remove the duplicate? How will you remove the duplicate? The same thing, right? How to remove duplicates in SQL? They'll ask you to write. So there are, multiple approaches are available. You can use different approaches to remove the duplicate records. First of all, how will you find out the duplicate? This is how we can find out. Okay. And the next one is the delete command. You can use the delete command to remove it. But what we will do is you can, what is that? I forgot. Common table expression. I used it once. I forgot. So using group by only, we can delete it. Okay. There is no doubt here. In this case, delete from, right? So you have something on delete from. table, the common thing. This is what you learn, delete from, right? Table name. For example, your table name is order details. Okay, where order ID, or product ID not in you can use select max of thing also, you can use it. Not in this one, right? So not this one. What you can use max of ID. You can find out the max of order ID, something like that. Okay. Probably I'll send you that query. Okay. And even I don't remember Tonda. But only thing is, this is how you can find out. Finding out is not sufficient. You need to remove it. Okay. You delete from order, where in this case order ID comma product ID not in your order details table. Okay. But in the order details table, if your order ID in product is or numeric value, it is fine. You can find out the max. Otherwise, it will be a little bit difficult, to find out. But the simple logic is you can use something like something like, you have only one column here. Okay, let's say you have something like ID column, employee table. Okay, ID not in, select max of employee ID. Okay, from your employee table, group by your first name, last name. That's all here. So you can, so here also we are using group by, or else simple thing is, yeah, here we cannot use max of ID, right? So maximum, see here, two records will be there, right? Already two records will be there for the combination. But of these two, you can find out the maximum one, that you can remove it, with this logic. And probably you can create some dummy table, create, this one with some number type, and then try it out with the combination of these two. And then the adventure database, what I will do is, right, when I get free time, I will share my link. A previous batch I covered how to install. You, without fail, you install it during your spare time, watch my video and then install it. And that database, you have a lot of tables. Data is also more, and you can start play around with queries. I'll give you some assignments, play around with it. That will give you more confidence. And yes, you have some queries regarding the DAX. The which one? The you mentioned about this one, right? Those of you thinking it's too late, you can probably drop off, and others can stay here. I will finish it off. He has a question, Nitesh. So he was asking, what is the difference between selected value and hash on value? So hash on value, both of them gives the same value. Both of them gives the same value. But in the case of hash on value, what it does, it returns the true or false. Okay, based on the filter context, you check whether this data has, this column has data in it or not. If it is there, then it will go and perform some kind of calculation. For example, here I just selected this one. Let me do one thing. I selected hash one value. This is the thing. In this case, the country column, and look here, in the country, if this one has any value, if this returns any value, this one will return either, see, as one value, it will go and check whether it has a value or not for the current filter context. If it is there, it will return true. Then you do this aggregation. Okay. If it is not returning anything, because we have used the has one value inside the if it is false, then you put not applicable. That's all. But whereas in the case of selected value, what it does is, you look here, not is blank or selected value, it is not going to return true or false. Instead, it will pick up the value. It will pick up the value as it is. If I select the Algeria, the selected value picks up the Algeria. For the Algeria, what is the sales here? So the selected value will have the Algeria country here. For that country, you find out the select. But here, not is blank and all I mentioned, right? So not function is not is blank. That means, non-blank value. You can use it here also. So in this case, with the combination not is blank selected value, but there you are using as one value. That's all, not much different. But yes, in the interview, to check your how how good are you with the different DAX function, they may ask you. So are you having a good flair of knowledge in various DAX functions? What is the difference between these two things? But end of the day, if you start talk about the scenarios, then it will be good. But the chances are high with this knowledge, the skill tuning, all the things. How do you, first question is, how do you find out the problem queries? In the case of Power BI, simply you tell them, I'll go to the view and we have performance analyzer. I'm going to select that one. In my report page, I remember that 5 to 6 visuals were there. When I selected this and when I started this one and when I clicked on the refresh visuals, I could, for a specific visual, I could see the elapsed time was very high. So DAX query was high, and then the display also high. And then I understood, so there is a culprit. Okay, the specific matrix was causing this problem. And then what I did, here in the performance analysis, copy visual option is there, and then we copied, and then we just checked the same thing in our DAX Studio also. DAX Studio, the advantage is server time is how long it takes. Formula engine, how long the query exists in your formula engine, how long the same query takes, how much time it resides in your storage engine. The rule of thumb is storage engine is if the query get pushed to storage engine, the performance will be faster because it has the multi-threading capability, whereas the formula engine, it executes each and every query individually because it's not a multi-threading. It cannot do parallel task. Okay, storage. But end of the day, when we replace the query, we have rewritten the logic, and for the same thing I've shown, right? So instead of filter expression, you can use skip filter. With that, we are able to see the drastic improvement, and also the storage. A lot of factors involved. Okay, your storage mode should be correct, data model design should be correct, and on top, your DAX query should be good. Above all these, your SQL server database should be created in a very optimized way. Storage parameters, many things are there. There are various parameters, but from our side, we have used the performance to diagnose of all the which visuals causes takes longer time. That visual we were able to rewrite it, and then after rewriting this, we tested with the smaller data, both the visuals. We could see that obviously there is an improvement in performance. And then what we did in the SQL server also, we there are some cases we cannot use the Power Query Editor, even DAX also not much helpful. Instead, in the case of directory, what we did, we wrote something like a stored procedure on the source system. That in that we were joining multiple tables. In the where clause, we were frequently using the region column, region key or column or something like that. In that case, what happened? We created an index and then we use the hint to enforce the query to use that index, whatever we created it. With that, we are able to improve the performance. Apart from this, the query logic also we changed it. Okay. And one more thing is, for example, in the case of left outer join, right outer join, if you change the order of the table, does the output also change? Yes, obviously, right? Let's say on the left side, you have the table. In the left outer join, you have the table A and table B. Let's say this is your product table. Left outer on your sales table. Left outer join. Okay, if you change the order of the table, B, left outer, one of the input they asked him. Okay, obviously the output will change, right? If you do left outer join, all the values from the table A will get written, matching values between the two tables and the rest of the values, which means all the data from the table. But this time, what will, since you change the order of the table, though you are using left out region, obviously all the data from your B side will get retrieved and the non-matching values between the two tables and the non-matching value from the, okay, only it will be fetched here, all the values from this here. Okay, obviously by changing that, this is one of the questions, right? You got stuck. Any other questions? Yeah, the leftover thing, I think with one class, we'll be able to finish up. SSIS, probably, right? I will cover it. I'll try to finish up this week itself, SSIS. And I will see the other pending things will finish up this week itself. Okay. From next week onwards, you're all set. we will, we will help you out in creating the profile, and our team will do that. And so they will start float your profile. A lot of openings are coming up, though recession is there in abroad and all, right? Still openings are there. We'll try to help you to place you, but end of the day, you should prepare very well, and you need to be well equipped, at least whatever I talk. Okay. Importantly, dynamic queries, performance tuning, and many-to-many data model design point of the last question. All right, guys, even I have another official meeting now. I will have to drop off now. We will circle back on this. Today is what day? Monday, right? It's Monday. This Wednesday we'll circle back, and I'll import the project. I'll explain on that day. Okay. Okay, I'm going to end this.